in the JEE PYQ section on the quick glance. So here I have taken up the example of relative order, the corrected relative order of acidity question, which is a very significant type that appears in the JEE and NEET. And here I have taken six examples so that I can teach you about variety of examples that may come in the exam. So the first one is the this meta substituted OTBU substituted phenol. The next one is the carboxylic acid, which has an sp2 carbon carbon linkage on the alpha position of the carboxylic group. Next, relative to this hydrogen, we have an alkyne in this group. This example where we have a CWME linkage on the beta position with respect to the hydrogen, this acidic hydrogen that we are talking about. Here this is the acidic hydrogen, here this is the acidic hydrogen. In the next example D, it is a para methyl sulfonic acid group where this is the acidic hydrogen. Next we have the para nitrophenol, and the last one is a cyclic alkene kind of cyclic system, Tanner system, where we have this F, which is actually constituting with a alkene and one sp3 carbon atom, which is termed as a cyclopropene. Now whenever we are comparing different kinds of groups, we have to first classify them, and actually we can have an order inside our brain. First one, here you can see this B is a carboxylic acid, right? And carboxylic acids are inherently much more acidic than the other acids, like this A phenol, or you can say this much phenol E. So B is obviously more acidic than A or E. And obviously A or E are phenols. Since they are aromatic alcohol, they will be much more acidic than C and E, F, because C and Fs are simple hydrocarbons. So C and Fs we are actually much less acidic. And the last one D, we have the sulfonic acid, and the sulfonic acids are very much strongly acidic because they actually generates this SO3 minus anion. This is the SO3 minus anion, and this SO3 minus is highly stabilized because of the equivalent resonating structure and the strong minus R effect of this SO2 group. And that's why this paratoluene sulfonic acid will be the strongest acid in this entire sequence. So D will be much more acidic than B. So now we have got an overview of idea that which will be more acidic or which will be less, but we have not even decoded the exact order. So let us decode the exact order. We have to see what is more acidic between A and E and what is more acidic between C and F, and then our job will be done. So between A and E, you see whenever you are talking about acids, you will see whenever we have a minus R and minus I containing group, and when it is in ortho or para position, that will be strongly acidic because of the resonance stabilization. So this E will be much more stabilized than this OTBU, because this OTBU is in the meta position, and in this meta position it cannot showcase its plus R effect, but it shows its weak minus I effect. But this NO2 actually shows a very strong minus R and minus I effect, and that's why E will be much more acidic than A. And next comes these two examples. The first one is C and the next one is F. Now C, you see in the example C, we have this carbon which is sp. Sp carbons are much more electronegative than the classical carbons. And here, since this, if the CH bond is cleaved, we have this anion MeOOC, C triple bond C minus, and this carbon ion is actually a bit stabilized because it is in the electronegative on the electronegative carbon, which is C. This sp carbons has 50% S character, which is much more electronegative than sp2 or sp3 carbon. Here in the example F, it is the poorest acid. It is so much poor acid that it will not even try to release one hydrogen, because if it releases one hydrogen, it generates this carbanion, and as you know, this carbanion is actually anti-aromatic in nature, and so on. As you know, planar system where there will be anti-aromaticity because they have the 4n pi electron. In complete conjugation they would be highly destabilized, and that's why this molecule never wants to release one proton to become anti-aromatic in nature. So the final order will be the most acidic will be D, then we have B which is carboxylic acid, and then we have this E followed by A, and next we have this C, and the last one is F. So this is the correct order, but this is the decreasing order. If the question is about increasing order, we'll simply flip it. So it will be F less than C less than A less than E less than B and less than D. So this is the correct increasing order, and this is the decreasing order. So that's how you can tackle the problem of acidity, by firstly grouping the compounds together, and then in the groups you will see which will be more acidic and which will be less. That's how you can actually have a comprehensive idea how to solve these kinds of acidity related problems. If there are all similar type of compounds, it will be easier for you, but in the examiner it wants to trick your brain, they will give different kinds of species. Because in this example you see this one is the sulfonic acid, this is a hydrocarbon, this is also, C is also hydrocarbon, B is a carboxylic acid, and this A and E are actually aromatic alcohols. So here different kinds of species are present. So that's why the relative comparison becomes difficult. So that's how you can tackle it. And thank you, and please subscribe our channel if you like the video.